Assalamualaikum and welcome to Cambridge Chemistry channel. Be sure to like the video and subscribe. Really helps the channel to grow. Today I will discuss qualitative analysis, paper 3, question number 3. Uh, where reagents are selected for use in test, the name or correct formula of the element or compound must be given. At each stage of any test, you are to record details of the following: color change, the formation of any precipitate and its solubility in an excess of the reagent added, the formation of any gas and its identification by suitable test. Uh, you should indicate clearly at what stage in a test change occurs. If any solution is formed, a boiling tube must be used. Rinse and reuse test tubes and boiling tubes where possible. Please follow these instructions before doing this experiment. Question number 3. FB6 is an aqueous solution containing one cation and one anion, both of which are listed in the qualitative analysis notes. Carry out tests to identify the cation. Record your test and observations in the space below. First, draw the table. Observations. Add 1 cm depth of solution in a test tube. And aqueous sodium hydroxide little at a time until in excess. And warm the solution. Fizzing can be seen fizzing of gas. Which turns damp red litmus paper blue. fizzing of gas of ammonia and sodium hydroxide when added in the solution. So this is the ammonium ion. The cation is ammonium. Now carry out the following test and record your observation. Test 1. To a 2 cm depth of Fb6 in a test tube, add few drops of nitric acid followed by a few drops of aqueous silver nitrate. Creamy precipitate cream PPTs are formed. Pour approximately half the contents of the test tube into the clean test tube. To one of the test tubes, add aqueous ammonia. So, cream precipitate are partially soluble in aqueous ammonia. Fp4 precipitates are soluble PPTs PPTs are soluble So these three tests confirm that Fb6 contain bromide ions because cream precipitates when silver nitrate is added, cream precipitates of silver bromide is formed, and these cream precipitates are partially soluble in aqueous ammonia or insoluble. So Fb4 precipitate is soluble when to the other test tube add Fb4 Na2S2O3. So Fb4 PPT is soluble. Reduce Fb6. So cation is ammonium ion. Cation is ammonium ion because ammonia gas is evolved when sodium hydroxide is added and warm the solution. And the anion is bromide ion. So the formula is ammonium bromide. Fe7 is acidified aqueous iron 2 chlorides. Carry out the following test. Observation. To a 1 cm, carry out the following test and record your observation. This is FeCl3. To 1 cm of Fb7 in a test tube, add 1 cm depth of Fb3 potassium iodide aqueous, then add starch indicator. So Fb3 Fb7 in a test tube, and a 1 cm depth of Fb3 potassium iodide. Fb3 gives red brown solution So red brown solution of iodine, because potassium iodide, iodine is displaced from this solution, so red brown solution is observed. And when we add starch indicator, solution goes blue or black. FB7 in a test tube, add 1 cm depth of FB4 and Na2S2O3. Leave to stand until there is no further change. FB7 is FeCl3. When we added in 1 cm depth of sodium thiosulfate, then it turns solution purple, and on standing solution turns colorless. And add sodium hydroxide, green, dirty green, precipitates. Explain your observation in B2 when aqueous sodium hydroxide is added. Iron 2 ions is present as iron 3 has been reduced by S2O3. C part is solid F8, contains one cation and one anion from those included in the list on page 14 and 15. Carry out the following test on F8. For each test, record your observations. In a hard glass tube, heat approximately half of the Fa8 gently at first and then more strongly. Leave to cool. Solid is yellow. Solid is yellow when heated. But goes white but goes white on on cooling. So if solid is, it means this is the zinc compound to a cm depth of to a 2 cm depth of dilute nitric acid in boiling tube. Add the remaining Fa8. Keep the solution obtained for test 3 and 4. Effervescence of gas is produced, which turns lime water milky. It means carbonate ions are present in this compound. Lime water milky conforms carbonate ion. To a 1 cm depth of the solution, 2 in a test tube, add aqueous sodium hydroxide until no further change. White precipitate, white PPT, white PPTs which soluble in excess of sodium hydroxide. To 1 cm depth of solution in a test tube, aqueous ammonia until no further change. White PPT which soluble in excess of ammonia solution. Use your observation from 1 to 5 ions present, zinc and carbonate ion. Fizzing confirm, fizzing and test. Confirm. And zinc, you know that hot zinc is yellow and on cooling is white on cooling. So this test and sodium hydroxide and ammonia test confirms that it is zinc ion, and fizzing and effervescence confirms that it is carbonate ion. So it's all about this question.